Hello? Hi. Wow. Okay, I know. You just gave up on that.
Friday, my dude.
It's Friday, my dude. All right. Is everyone planning on showing up today after school?
Friday, my dude.
Okay, good. So that's going to tell me like where I'm going to stop at anyway. So if I can get much as I can done now, but then I'll finish it after school today, and then we'll go over the rest of it. All right. So Taylor series, Maclaurin series. So suppose f is a function. Okay. And that has derivatives of all orders in the open interval of c minus r, comma, c plus r, which is my, what is r? The radius convergence, right? So somewhere in between there. Okay, so whatever my c is, which is centrally located, so it's going to be the minus r, the plus r, right? Yeah, like the problem we just did, right? So if c, on that last one, the c value would be 0, right? Because 0, then it was a minus r, which is my 3, and then it was a plus r, which is a positive 3, right? Okay, good. All right, so if f can be represented by the power series, whose radius convergence is r, then it could be written like this, and such, and comes out to a equation like this, where this f of k, it has to do with the how many derivatives I did to get those terms. So we're going to turn a function into a series. Okay, so this one right here, Taylor series, and a Maclaurin series is one where c equals 0. So Maclaurin, yay, Taylor, okay. So we're going to try and figure out first. Okay, first thing I'm going to start with some Maclaurin, and then I'm going to try and get to some Taylor. Okay, because that one's going to be easier. So now all the time when I'm doing this, they're always going to be centered around 0. They're going to be centered around 0. So when I'm actually doing this, I do x, what is my x value? So when x is 0, y is bleh. And that has to do with my series here. Okay, so first, I have this as my function. Say yes. Okay, so let's go f prime of x is e to the x, thank you. F double prime of x, oh please don't tell me you're doing this again. Okay, f triple prime of x is, woo, there we go, e to the x. So, where did I say we're plugging in at? Everyone say 0.
0.
Where do I plug in?
0.
So I'm always trying to figure out around.
0.
So this time it's going to be from? Okay, good. So f of 0. Let's start with f of 0. So f of 0 is, f prime of 0 is, f double prime of 0 is, f triple prime of 0 is, okay. So, patterns. I love patterns. Patterns are great. So the pattern goes like this. It's going to be f of 0 plus f prime of 0 x over x to the, there's an x and a k. I don't want to mess up the k. All right, right here. Okay, there it is, right here. So this is over 1 factorial. I don't want to mess up that one. So, okay, so over 1 factorial plus f double prime at 0 times x squared over 2 factorial plus f triple prime of 0 times x to the third over 3 factorial. I just wrote a whole bunch of stuff. Yes? Now, I'm going to try and turn this into a sum of series. Alright, so let's see what my values are going to be. So this is, we get 1 plus x, which is, okay, this is plus x squared over 2 plus over 3 factorial. Let's just go with the factorials because it'll make sense here in a second. And it'll be 6, not 5. 3 times 2 times 1.
Oh yeah, it's times.
Okay, it's fine. All right, so now let's see. Can you tell me what the patterns this is going to be? Are they all staying the same sign? Okay, good. Stay in the same sign. So we're going to say that I have the sum as k equals 0. So if they're staying the same side, do I need to input like an alternating series or something out of it? How would I make it an alternating series? -1 to the k value here, right? Okay, some type of k. So 2k, 3k, something like that. Okay. Now, so if I'm starting with k equals 0, how would I write this? How would I get these terms right here? X to the power of k over k factorial. X to the power of k over k factorial. Now, that's exactly right. There's one thing I don't like, but it's still right. I don't like it. I had to Google it because it makes me mad. It's one of those things that it's an itch in my brain that like, I'm like, ugh, that's so nasty. Huh?
That makes sense.
Jimmy says that makes sense. He showed it to me, but he didn't understand why he was showing it. So.
Okay, Jimmy. Indulge us.
So 3 factorial is 3 times 2 times 1, which is 6. 2 factorial is 2 times 1, which is 2. So you went from 6 to 2, so you divided by 3. 1 factorial is just 1. So then you went from 2 to 1, so you divided by 2. So then the next one you divide by 1. So you went from 3 to 2, you divided by, you went from 6 to 2, so you divided by 3. And then you divide by 2.
So 2 to 1, you divide by
And then
2.
you divide by 1.
Oh, okay, hold on. You know, I'm getting lost, all right? Okay. So we're starting with 3 factorial, right?
Yeah.
So 3 factorial is 2 factorial is 2. 1 factorial is
1.
So then look at the pattern.
You divide
So
by
you
3. You divide by 2.
and
The
then
next one you divide by 1.
and then so that one you divide by 1. So then 0 factorial, you divide 1 by 1.
Which is exactly
Yeah.
0 factorial is.
And then to get -1, you flip it all around.
okay. So what about does it? Okay, so what about 4 factorial?
You just multiply it by 4, obviously.
4 factorial is
600.
Does the church know about this?
the church lost its power 600 years ago.
okay. 4 factorial 24, right? So divide that by 4.
You get 6.
So we're saying divided by 4 is 6, divided by 3 is 2, and divided by 2 is 1, divided by 1 is 1.
So then what would make it equal to
It stops at 0. Negative 1 is negative 1. It doesn't, you don't, you just don't. You divide 1 by 0.
Okay.
Is somebody gonna ask that?
Hey,
I asked
you know what?
him.
I googled it. I'm like, what the? Okay, all right, fine. I'll just say yes. Good job, Jimmy. All right, good job. All right, you have enlightened us all.
Candy points?
Does he get what?
Is he good at cooking?
Do you want a cookie?
I'm alright.
Okay, he wants no cookie.
Bobcat buck.
He wants a Bobcat buck.
Give him, we want him to have a pup.
Okay, so yeah.
It's not his choice anymore. It's ours.
Okay, so as a whole, he deserved it. Anyway, all right. Theorem: Taylor's formula with remainder. So this one right here, it's going to be f of c, which is wherever I'm starting at here. Where okay, I'm sorry. Let me start at the beginning. So let f be a function whose first n plus 1 derivatives are continuous on an open interval I containing the number c. For every x in I, there is a number u between x and c. There's a u somewhere between x and c. For which f of x is equal to f of c plus f prime of c, and then it's x minus c, double prime, and then, so it's the same concept, but this case right here, I'm doing x minus c. For this one, it's on the Maclaurin, I just did x, right? Now in these cases, I'm going to do an x minus c. Yes? Okay? All right, good. So where I should come up to this, right, where that's the derivative, right? N plus 1 would be the derivative of u, n plus 1 factorial, x minus c to the n plus 1. So that's how many terms I'm getting out of that. All right, so is the remainder after n terms. The remainder, Rnx, contains the n plus 1 derivative of f evaluated at u. Okay. Okay. Convergence of a Taylor series. If a function f has derivatives of all orders in an open interval I, blah, 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 where r is greater than 0, right? Okay, so centered at c, right? That's some value that I have the radius on both sides, right? Okay, good. All right, and if the limit as n goes to infinity of that, we get the limit as n goes to infinity of the derivative n plus 1 of u over this whole thing. All of it has to come out to be 0. For all numbers x in I where u is a number between x and c.
That's the funniest sentence.
Yeah.
You like this?
No, just for all
Numbers
numbers
x
x
in
and
I,
I,
u is a number between c and x.
Okay. Anyway, so this is going to, yeah. Anyway, so convergence of a Taylor series, and for this right here, so for the function, same thing. We have the k of the series here. We set it up, keeps going all the way out, and then for all numbers in I. So whatever that open interval is. Show that this converges to e to the x for every number x that is proved. That works out. So, if it's going to converge, right? Let's talk about the previous slide. I think it's previous. If it's got to converge, then what has to happen? Okay. So we're going to get a convergence, and then we're going to have that is going to come out to be this. So if this is my series, if this equals this, then it's going to come out to here. So in a sense, I'm going to say that e to the x is equal to the sum k 0 infinity x to the k over k factorial. I'm basically saying that's going to happen. Gotta double check my notes on this one. All right, so I know it's going to come out to be this, right? Because I have my function, right? So f of n plus 1 of whatever my u is, right? Times to the x to the x plus 1 over x plus 1 factorial. All right, previous slide. N, yes, you're right, n plus 1. I'm sorry. Ah, no, give me. N plus 1 factorial. There we go. All right, so that thing right there. I know that the derivative is always going to be e to the x, right? E to the x, but in this case it's going to be to the u, right? This is from the previous slide. So this is going to be e to the u. So e to the u, and I have x to the n plus 1. Man, my board's not liking me today. N plus 1 over n plus 1 factorial, right? And there we go. All right, go back over that. So we know that this right here, because I'm going to have some value u, and it has to be less than what? Between x and c, right? Okay, so it's going to be between x and c. So in this case right here is somewhere between x and c, right? Somewhere in between there. So I know that that function right there has to be less than the e to the x, right? Because if I'm plugging in at both points right here, I have a x and I have a c, right? So it's somewhere between there, so that that function has to be less than e to the x of x to the n plus 1 over n plus 1 factorial. Do you guys understand where the x came in and why there's a u in there? Because u is somewhere in between those two. Are we okay? So I know that somewhere in between there that's going to work. So now let's see. This will work out if it converges. Can I test to see if this piece right here is going to converge? Say yes. Yes, I'm gonna see if it's going to converge here. So as I converge, because I'm just going to test this piece because it's going to be the same in both, right? And so if it converges, it's going to be a convergent times this, and it's also going to be convergent times this, right? So I'm going to basically having the same thing here. So we're going to see if this works.
Okay.
So I'm going to go to another page, and I'm going to do this. So which test do I want? What test do I want? What test do I want to do for that? Ratio test, right? Okay. So I'm doing a ratio test on that. Man, that thing, something's not liking me today. Computer's going off. All right, so come on now. Come on, you can do it. All right, okay, let's go back. Next page. All right, so for right here, I had it set up. So I'm going to have my ratio test, which is going to be I'm just going to test the x to the right over n plus 1 plus 1 factorial, right? All over x to the n plus 1 over n plus 1 factorial. Computer's not liking me today. So this is basically n plus 2, right? On top, so I have n plus 2. So I'm going to have, rewrite it out, so it's going to be x to the n times x to the 2 over, that's going to be n plus 2, right? So I'm going to rewrite it like this, n plus 2 times n plus 1, right? Factorial. And it's going to be times the reciprocal at the top, which is going to be n plus 1 factorial over x to the n x, just x, right? Okay, do a lot of canceling. So we get those, and I get those and those. So as I'm taking the limit as n goes to infinity of x squared over x to the n plus 2, right? As n goes to infinity, what do I get? Go ahead, say it, Alex. 0. Because the only thing I'm actually taking to infinity is the n, right? So as n goes to infinity, I'm not worried about the x's because the x's, there's some radius, right? Some convergence in there, so it's going to converge at certain things. So we have math for this, but as n goes to infinity, this is going to go to 0. Yes? Because I only have an n on the bottom, I cancel out all the top. So for this one right here, I have now shown that converges to 0, and so this is, if I factor it out for both of those limits, I now could say that e to the u is going to be less than e to the x. There we go. more math, I could say that u, right, will be less than x. For whatever in this radius of convergence. So, inside that radius convergence, I do have this one right here. So, in this case right here, my radius is actually 0. Right? So, this is like a Maclaurin series where it's going to be 0, right? So, it's right there. There is no difference in between your x or your r plus or your r minus. It's going to be just right there. So in this case right here, I now have that this is for every u, it's going to be less than x. So it is going to be convergent for all real numbers. Now, the proof sucks. Let's do some more patterns. That's easier. Because it looks like everyone's falling asleep, or at least trying not to fall asleep. You'll feel better about this next one. I guarantee. Maclaurin series. So we're going to start with f of x is this. Alright, so let's go through and start doing my derivatives. F prime. It's what? Cosine x. F double prime. F triple prime. That's basically as far as we need to go, because we can take the derivative for all these and keep going, right? Okay, so let's start plugging in our numbers. So f, so where's this centered around 0, right? So it's going to be f of 0 is 0. F prime of 0 is going to be 1. F double prime of 0. F triple prime of 0. Okay. Patterns. So what is going to be my first term? 0. Because my first term, if I go back, it's going to be f of c, right? Yes? So it's like this in the Taylor, and Maclaurin is just, the c is 0. Where am I at? Maclaurin down here. The c is 0, so it's just going to give me that, right? So it's going to be f of 0. Yes? Okay, good. So keep going. All right, so my first term, 0. Next one's going to be plus. What is f prime of 0? 1 times x over 1 factorial. It doesn't have the 1 factorial there, but in my mind, and a good step, write it out so you can see it. It's a little bit easier if you see it in the pattern. So next one, plus f double prime, 0 times x squared over, good. Next one, -1 times x cubed over Okay, we good, right? Now let's do a little bit of math to actually see what we get here. So my terms now are going to be 0, right? Plus x.
X over 1.
Yeah,
So
it's
it's just
okay,
x.
yeah. So that's going to be x, right? I'm going to leave the factorial here. It helps with the pattern. Okay, so what happens to that?
0.
That goes away. That's 0, right? And so what would be my next term? Minus factorial, right? Okay, so what would be next in the pattern? Now, we did all these terms right here, right? We did the terms. I don't think I need to actually keep going because the sign, okay, we've actually gone all the way around the sign circle, right? For all the derivatives. It's just going to keep repeating, right? Okay, so now what would be the next one here? So let's see, right here, what would I have? Just look at the terms I have now. So it's plus, right? Plus
X to the 5th over 5.
x to the 5th over 5, factorial. That's what I'm looking for. I'm looking for the pattern. I use this right here because I know every other one's going to go away, right? Every other one's going to go away. And so, okay, so what would be next in the pattern? Yep, minus x to the 7 over 7 factorial. Are you guys seeing this or no? Anyone struggling? Patterns, patterns, patterns. Now, can we make a sum? We're gonna do what is this now gonna be? So I'm gonna call this now. I want you to think about how is it I'm gonna represent this. No. -1 to the what?
The K.
Yes, that type of thing. But if I were you, I would not include the 0 because 0 goes away, right? So it's really not one of the terms anymore. So you said -1 to the K.
It's like alternating.
-1 to the K. X to the K over K factorial.
Wait, but then it skips.
Okay. So looking at it now, that it's supposed to skip, right? So there's not supposed to be a 2, is there? Okay. So let's clear that up. But I still agree with the first part. The first part would be fine. Brenda, what do you think? K plus 1. -1 to the K plus 1. Okay, look at the pattern, okay? So, again, let's get rid of this first, okay? The zeros out of there. So, -1 to the K plus 1. So, if I'm starting K at 0, plug in K, you get 0 plus 1, which is -1 to the 1, right? So -1 to 1 is going to give me a negative. So is my first term negative? No, it's not. So that's the reason why I'm going with just K. So -1 to the 0, just 1, right? Negative 1 to the 2. Oh, I'm sorry, no, 0. I'm sorry, 1. There we go. All right. So negative 1 to the 1 is going to be a negative, right? Okay. Here's a negative. Negative 1 to the 2. Okay, that's a positive. Negative 1 to the 3. That's a negative, right? That's what I'm saying. That part's right. So I'm looking for the next part. All right, here's a hint. There's an X.
That adds 2, that adds 3, that adds 4. How do you do a power that adds? So it does 0 plus 1. And then the second term is 1, and then it becomes 3, so it's 1 plus 2. The second one is 2, becomes 5, so it's 2 plus 3. Next one is 3, and then.
But remember, we're starting here.
Yeah, that's what I'm saying. Because the first, when k equals 1, is negative x cubed.
My first term should be 0.
Yeah. So
Oh.
the second one is 1. K equals 1, right? The second term is k equals 1.
This one,
Yes. K is 1.
it doesn't have to be k plus 1.
Not just k plus, no, just k is 1. Like that's.
So we see a pattern on it, right?
Yes.
Are they always odd? Yeah, go ahead.
X are 2k plus 1.
2k plus 1. Multiply any number by 2, it makes it even, right? Any number by 2 becomes even. But then since all my digits are odd, I just add 1 to get the next. And so let's see, does that work for my pattern? So as I enter 0, because my first term is starting at 0, 2 times 0 is 0 plus 1 is, oh, there it is, x to the 1, right? That's good. Okay, so now what about my bottom numbers?
Uh, 2k plus 1.
2k plus 1? So you're saying 2k plus 1 factorial? Let's see what we get. So as I start plugging in, 0, that would be 1. 1 factorial is 1. Okay, plug in the next term, which would be 1. So that's 2 plus 1 is 3. 3 factorial. Yes? Okay, yes, this is it. Problem solving. Okay, that's all what all this is. Okay, you have to look at it and see, good job. All right, so we're gonna finish this one right here. Let's show that it converges to sign for all numbers x. We're gonna get to that later. All right, so let's see. Yay! All right.